Hello, today we are going to discuss on the topic of process state. At the end of this session, students will be able to explain the concept of process state in the operating system, draw and explain process state diagram. Talking about process state, we know already process is created and the system assigns its state, or we define a process is program instance which are currently being executed in the operating system. Process descriptor describes the current state of the process when the process runs from the ready queue, and the value of the state field is usually set with a simple assignment as shown in the example as P state is equal to task running. In this example, P stands for process, state stands for state of the process, and task running stands for the currently running process in the processor. The process always have the different ID and different process number which are assigned by the CPU in the operating system. Operating system always does the scheduling for the process which consists of process state and process running, where we simplify this example with the help of P state is equal to task running. Now, processes are in one of the two states. One is running process. We can say the process that is on the CPU, it is a running process, and a process which is not on the CPU, that is of the CPU, it is not running process. Here we say only one process can run at a time on a single CPU. If you want to run multiple processes on the multiple core of the CPU, the states have been defined in the different processes of the operating system. And here all other processes have to wait or be in some other state, because the process has to keep a queue for all the processes and they have to wait and ready for the other state of the running process.
Start 10 मिनट 10 सेकंड.
Now we look at process state diagram which has 6 states. One is running ready state, the second is running state, third one is waiting state, fourth is blocked state, fifth is terminated state, and sixth is finished state. So these are the 6 states which has the process state diagram. First of all, we talk about the running state, which we can call it as a created state. When a process is first created, it occupies the created or new state. In this state, the process awaits admissions to the ready state. Admission will be approved or delayed by a long-term or admission scheduler. Typically, in most desktop computer system, this admission will be approved automatically. However, for real-time operating systems, this admission may be delayed in some cases. In real-time system, admitting too many processes to the ready state may lead to oversaturation and over contention of the system resources. So what the processor will do is, processor will take the lead to an inability to meet the process deadlines. Then we go for the ready state. A ready state or waiting process has been loaded into main memory, because when we execute the program which we load into the main memory, and it is awaiting execution on a CPU, which is a context switch on the CPU by the dispatcher or the short-term scheduler. There may be many ready processes at any point of the system's execution. For example, in a one processor system, only one process can be executing at any one time, and all other concurrently executing processes will be waiting for execution. When we talk about a ready queue or run queue is used in computer scheduling, where modern computers are capable of running many different programs or processes at the same time. However, the CPU is only capable of handling one process at a time. Processes that are ready for the CPU are kept in a queue for ready processes. Other processes that are waiting for an event to occur, such as loading information from a hard drive or waiting on an internet connection, are not in the ready queue. Then we go for a running state. A process moves into the running state when it is chosen for execution. The process's instructions are executed by one of the CPUs or core CPU, we can say, of the system. There is at most one running process per CPU or core. A process can run in either of the two modes, namely kernel mode or user mode. In the kernel mode, processes can access both kernel and user addresses. Kernel mode allows unrestricted access to hardware, including execution of privileged instructions. Various instructions such as IO instructions and halt instructions are privileged and can be executed only in the kernel mode. A system call from a user program loads to a switch to a kernel mode. Then we talk about user mode. Processes in user mode can access their own instructions and data, but not kernel instructions and data, which are those of other processes. When the computer system is executing on behalf of a user application, the system is in user mode. However, when a user application requests a service from the operating system via system call, the system must transition from a user to kernel mode to fulfill the request. Now in process state diagram, typical process states are possible on computer system of all kinds. First, new, when a new process is being created. Running, a process is said to be in running state when instructions are being executed in a processor. Waiting, the process is waiting for some event to occur such as IO operation, input output operation. Ready state, the process is waiting for a processor. And terminated, the process has finished execution. Now, after this process state diagram, a processor informs the process control block for storing the necessary information. Process control block is a data structure which contains the information about all the processes. First one is a pointer, which is a stack pointer which keeps the pointer to the parent process. Process state stores the respective state of the process. Now what we have seen is running state, ready state, terminated state and waiting state. These states are stored in the process state. Process number, there is a 10-digit unique ID which stores the process identifier. Program counter stores the counter which contains the address of the next instructions that to be executed for the process. Register, which includes accumulator, base register and general purpose register, which stores the value of the variable which is required during the running of the process. Memory limits, memory management system used by operating system which include the page table, segment tables, etc. And open file list, it comes under the IO status information which includes the list of files open for process and list of resources required for the process. Let us pause for a while and see the question: what changes need to be incorporated to the process state diagram shown for an OS running on a dual core system? Yes, the answer is none, because in the process always has the 6 states. So every core system has also 6 states, so which were a processor running, that is from the running state to the terminated state. So there is no need of change in the process state diagram which are running on the core system. So that's why the answer is none. These are the references. Thank you.